Okay, so we were left with that one. Now, for those of you all that don't see it right away, I can go ahead and rewrite this as the following. This right here is telling us that we are going to have two of those signs. So I can just rewrite sine squared as sine of theta times sine of theta. Now, one of these right here will cancel out with this one right here at the top. So when they cancel out, that leaves me with 1 over cosine theta sine theta. Cosine of theta sine of theta. Now, we can always split up this fraction. They're being multiplied with one another, so we can always go ahead and split it up into two fractions, multiply with one another. So I can always say that's the same thing as saying 1 over cosine of theta times 1 over sine of theta. You get the same thing. 1 times 1 is 1, like we get here. Cosine of theta times sine of theta is cosine of theta sine of theta. Now, if we remember our identities, this is where we have to go back to our identities. 1 over cosine of theta is secant of theta times 1 over sine of theta is cosecant of theta. Okay, so let's just double check to see if this is what we were supposed to get up there, because I don't remember. We were supposed to get secant of theta times cosecant of theta, and that's exactly what we got. Remember, if I would have gotten the cosecant first and then the secant, it's the same thing, because multiplication you can add forwards and backwards. 2 times 3 is the same thing as 3 times 2. So even though if you would have gotten cosecant here and secant here, that still would have been a correct answer. All right, so therefore, let's go ahead and end it the appropriate way. That is equal to that. And there we go. That is number 8. We had a little bit more to do, but we were still able to do it. All right, now we are going to look at number 10. Number 10 is saying 1 over secant squared of theta plus 1 over cosecant squared of theta is equal to 1. Alright, so obviously the left-hand side one looks the most difficult, but you just got to remember your identities. 1 over secant is cosine, so 1 over secant squared is cosine squared, plus 1 over cosecant is sine, so 1 over cosecant squared is sine squared. And remember, addition is the same thing if they're both positive with multiplication. 3 plus 2 is the same thing as 2 plus 3. So sine squared of theta plus cosine squared of theta is equal to 1. And also cosine squared of theta plus sine squared of theta is equal to 1. So no matter if the sine squared was here first or the cosine squared of theta was here first, it's still going to equal 1 because it's an identity. Now, is this the same thing we were supposed to get? Yes, it is. So let's go ahead and finish it. So therefore, 1 equals 1. All right, let's look at number 12 and see what we can do there. All right, number 12, I'm going to go ahead and type it up here. So I have secant of theta over cosine of theta. And minus tangent of theta over cotangent of theta. And that's equal to 1. So obviously, you can kind of know which side you're working with, and that's going to be the left-hand side, because it looks a little bit uglier than just the right-hand side, which is 1. So I think at this point, our best bet is to just go ahead and change everything into terms of sine or cosine, and you may not need to. I'm thinking we're going to change this one. And I'm thinking I want to change this one. So let's do that. Let's do that. I'm going with the hunch, so we're going to go ahead and do that. So if you remember secant of theta, that is 1 over cosine of theta. Now, this method right here is going to be a copy, change, flip. And I'm going to go ahead and change this cotangent of theta because that is 1 over tangent of theta. Now, this one right here will be a copy, change, flip. So let's go ahead and do that. So I'm going to go ahead and copy, change, and flip. Flip this one. When I flip it, it becomes actually the exact same thing. It becomes that. Minus. Let me go ahead and copy, change, flip this one. So I'm going to copy this one. And then when I flip this one, I get tangent of theta over 1, or simply tangent of theta. So now what I'm going to do is I'm going to go ahead and multiply these two together. Top times top, so that gives me 1. And bottom times bottom, so that gives me cosine squared of theta. So I'm going to get 1 over cosine squared of theta minus, and when I multiply both of those tangents, I get tangent squared of theta. Okay, the last step is to go ahead and change this to, this is another identity. 1 over cosine is secant, so 1 over cosine squared is going to be secant squared of theta. So it's going to be secant squared of theta minus tangent squared of theta. And then you should be able to know that that is an identity that is equal to 1. And is that what we were supposed to get up here? Yes, it was. So we're going to go ahead and finish it. And say that, therefore, 1 equals 1. And that's it. That was number 12. All right, number 14. 14 looks like a good one, so let's just check it out. So we have secant to the 4th of theta minus tangent to the fourth of theta equals tangent squared of theta plus secant squared of theta. Alright, so I have secant to the fourth of theta minus tangent to the fourth of theta equals tangent squared of theta plus secant squared of theta. Now obviously the ugliest side is going to be the left side, just because those exponents are a little bit higher than what you're used to. You're used to seeing them as squares. But you should also notice that this right here is going to be able to factor into a difference of squares, but just to another higher power. So we're going to go ahead and start with the left-hand side. And what do we know about a difference of squares? Well, we know that one is plus, and the other one is going to be minus. Alright, so that when I factor it out, how can I get secant to the fourth? Well, I can get it by saying secant squared of theta secant squared of theta times secant squared of theta. Alright, well, how can I get tangent fourth of theta? Similar thing. Tangent squared of theta and tangent squared of theta. Okay, so we have factored it out. And now you should be able to see something. Alright, you should be able to see that one of these is going to be an identity, and I believe this one is going to be this one. This one, because I actually think we just did this one. We used it in the previous problem, but I believe that that one will be equal to 1. All of that will be changed to 1, and anything times 1 is itself. So we're left with this right here. So we're going to say, therefore, secant squared of theta plus tangent squared of theta is equal to, well, wait a minute, is it equal to that? Yes, it's the same thing, you know, because this tangent squared of theta is positive, this tangent squared of theta is positive. This secant squared of theta is positive, this secant squared of theta is positive. So even though they aren't in the right order, the signs are the same. Remember, 2 plus 3 is the same as 3 plus 2. Alright, so that is number 14. Okay, we're going to go ahead and move on to number 16. Alright, so number 16, let me go ahead and type that out. One minus sine squared of theta times 1 plus tangent squared of theta